In Chapter 4, Section 3, what we're working with are parallel lines and perpendicular lines. And what we need to understand about parallel lines is that lines that are parallel have slopes that are equal. So parallel lines have the same slopes. If we're trying to find out whether two lines are parallel, all we have to do is look at their slopes and see if they're the same. So let's look at line A, the blue line. We're going to use the formula for slope, which is m is equal to y2 minus y1 over x2 minus x1. We could also use the graph, it's fine. So we have y2, let's label our points, x1, y1, x2, and our y2. So we have 2 minus 3 over 1 minus negative 4. And so we have 2 minus 3 is negative 1. 1 plus 4 is 5. So we have a slope of negative 1/5. And we can see that that's good by moving down 1 over 1, 2, 3, 4, 5. So m is equal to negative 1/5 there. B, the red line. We have m is equal to, let's label our points, x1, y1, x2, y2, and we have negative 1 minus 0 over 1 minus negative 3, and so we have a negative 1 over 4. So for the red line, the slope is negative 1/4. We can confirm that. Go down 1, right 1, 2, 3, 4. The green line, C. We have m is equal to, label our points, x1, y1, x2, y2. y2 is negative 5 minus y1 is negative 4 over x2 is 2 minus negative 3, and we have negative 5 plus 4 is negative 1, and 2 minus negative 3 is 2 plus 3, which is 5. We can confirm that by down 1, right 1, 2, 3, 4, 5. So we have a slope of negative 1/5, whether we use the graph or we use the formulas. Now, which of these lines are parallel? The lines that have the same slope will be parallel. So A and C are parallel. All right, and that does it for example 1. Next, for example 2, we want to write the equation of a parallel line. What does that mean? We want to write the equation of a line that passes through the point 5, negative 4, and is parallel to the line y equals 2x plus 3. So let's use our graphing calculator to see what we're trying to accomplish here. So what we want to do is put in this original equation, y equals 2x plus 3. So we go to y equals, and we put in y1 equals 2 times x, which is up here, plus 3. And then what I'm going to do is always zoom standard. That's zoom 6. And what I can see here is the line y equals 2x plus 3. Now, what I want is a new line that is going to be parallel to that line and passes through the point 5, negative 4. So I put a copy of the graph there. It's not the greatest graph. However, you can see that this is the line 2x plus 3. We have that y-intercept of positive 3 there. Now what I want is another line that is going to pass through the point x is 5 and y is negative 4. So that would be right about this point. So What I need then is a line that's going to be parallel to the other line. So my new line is going to have to look something like this. All right, so I don't want to use the original line, but what I need from the original line is its slope. So I know that by looking at this, that that line has a slope of 2, and I'm going to use x1, y1 from the new point that I have. And I'm simply going to use the point slope form. If you remember, that's y minus y1 is equal to m times x minus x1. So all I need to do now is plug in what I have. Y minus negative 4 is y plus 4 is equal to 2 times parentheses x minus 5. When I distribute, I get 2x minus 10 is equal to y plus 4. I'm then going to subtract 4 on both sides, and I end up with y is equal to 2x minus 14. Now, we can't see 14 down here, but it's going to be somewhere below negative 10, and so that makes sense there. So our new line would be y is equal to 2x minus 14, and that passes through the point 5, negative 4, and is parallel to the line y equals 2x plus 3. Well, what I'm going to do now is bring up the graphing calculator again, and let's put that new equation in. So I go back to y equals. This time I don't write over the equation that I have in there already, 2x minus 14, and I simply hit graph, and you can see there that um, I have a line parallel to the original line. It looks parallel, and it also passes through the point x is 5, y is negative 4. All right, so that's what we're trying to accomplish here. We want an equation of a new line that's parallel to the old line. That means it has to have the same slope as the old line, but it passes through the point 5, negative 4. So we use the slope from the old line, we use the point that we're given, and we plug them into the point slope form and come up with a new equation. Okay, then the next two problems are really meant to see whether or not you can do the same thing. So, number 1, monitoring progress. Line A passes through this point, negative 5, comma 3, and negative 6, comma negative 1. Line B passes through 3, negative 2, and 2, negative 7. Are the lines parallel? Explain. Well, we know that lines will be parallel when their slopes are the same. So, we'll look at the two lines. Line A has a slope m is equal to y2. So let's label our points here. I'll use two different colors. x1, y1, x2, y2. So we have negative 1 minus 3 over negative 6 minus negative 5. And that comes out to be negative 4 in the numerator. You really have to watch out for your negative signs. Use your calculator if you need to. Negative 6 plus 5 is going to be negative 1. Negative 4 over negative 1 is positive 4. So the second line, that's line A. Line B, and we'll label our points in green this time, x1, y1, x2, y2, and m is equal to negative 7 minus negative 2 over 2 minus 3. Negative 7 minus negative 2 is negative 7 plus 2. Negative 7 plus 2 is negative 5. 2 minus 3 is negative 1. Negative 5 divided by negative 1 is positive 5. Are the two lines parallel? No, because they have different slopes. So that does it for problem 1. Again, if we're trying to see whether two lines are parallel, what we need to do is find the slopes of each of those lines. If we're given an equation, we can solve for y equals mx plus b and find the slope that way. If we're given 2 points, we can use m equals y2 minus y1 over x2 minus x1 and find the slope that way. Then eventually what we need to do is just compare the two slopes. If they're the same, the lines are parallel. If they're not the same, then the lines are not parallel. All right, so let's go on to problem number 2 here. Write an equation of a line that passes through negative 4 comma 2 and is parallel to the line y equals 1/4 x plus 1. Well, we're going to look at our original line. This is not the line that we want, but we want to be parallel to this line. And if this line has a slope of 1/4, then our new line has to have a slope of 1/4 and pass through the point negative 4 comma 2. So we're going to use point slope form. Y minus y1 is equal to m times x minus x1. Plugging in y1, which is 2, we have y minus 2 is equal to 1/4 times x minus negative 4, or x plus 4. Watch out for the negatives. Distributing, we get 1/4 x plus 1, y minus 2. We're going to add 2 to both sides, and we end up with y is equal to 1/4 x plus 3. Y is equal to 1/4 x plus 3, and that is all that we need to do here. Now we have a new line that's parallel to the old line. We know it's parallel because it has the same slope, but different y-intercepts. Okay, so that's going to do it for the first set of problems, which have to do with identifying whether lines are parallel by looking at their slopes, or finding a new line that's parallel to another line by finding the slope of the original line and given a point using the point slope form to find the equation of a new line. So that'll do it for this video.